Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to second PU Computer Science online classes. In last class, we already completed some concept. The concept are maybe why spreadsheet is not called a database, data abstraction here, and maybe some of the DBMS architecture, internal level, conceptual level, external level here, and also the DBMS users. Now, in today's class, we are going to learn about some new concept, that is different types of the architecture. So, the different types of architecture, we know the meaning of the architecture, design of the database. So, DBMS, that means our software, is highly depend on its architecture, design of the database. And the design of the database can be centralized or decentralized, meaning of centralized. Here, data is stored at central location and such data can be accessed multiple users, or sometimes the data is not possible, that is called as the decentralized. So, DBMS architecture can be viewed or seen as single tier, multi-tier, n-tier architecture. So, different type of the design of the database are there, and we can see maybe single tier, multi-tier, n-tier architecture. And the n-tier architecture which divides the whole system into related but independent n modules. That means which can be easily, separately, independently modified or altered, changed, replaced here. No any problem. Why? Because n modules which can be divided into related but going to perform tasks separately. They are related but also going to perform the task separately here. So, we can say that why? Because the database architecture is divided or logically divided into three types. The types are logical one-tier in one-tier architecture, logical two-tier client-server architecture, logical three-tier client-server architecture. Why? Because three types are there, and such one is called as the different types of DBMS architecture here. So, the architecture, database architecture is logically divided into three types. So, now we are going to learn about the first types, that is the logical one-tier in one-tier architecture. What's the meaning of logical one-tier in one-tier architecture? We know DBMS, it's a software. So, the DBMS is only the entity where user, here user means the application programmer or the database designer. So, the where user sit on the DBMS and uses it. Clear this point here? The DBMS is only the entity where maybe the application programmer, or we can say as the system designers in this case here, or the database designers here sit on the DBMS and uses it here. And later words we can say that any changes done here will be directly done on DBMS itself. That means here we can say that the user, it's not possible to do whatever the changes they want in our database. The user or the end user, it's not possible to do such changes. So, whatever the changes they want to do just by using the software, and such a software is going to, that means used by our application programmer and database designers. So, that means we can say that any changes done here will directly be done on DBMS, who are using the DBMS here, such person going to make some changes in this case here. And here we can say that the end user, that means the end user not providing any kind of the tool in this case here. That means here we can say that the end user not provide any kind of the tools to make all those changes, and simply or preferably the database designer and the programmer use the single tier architecture. Clear this point here? That means what's the data in simple meaning? We can say that I want to create the database. That means such a database is created by our database designer here. Correct? No? First of all, choosing the appropriate structure and later was representing or store the data one after the another, and whatever the data they stored later was just only it work of the end user to view the data of the database here. So we can say that here logical one tier in one tier architecture. That means any changes if they want to make, the user want to make any changes, it's not possible to do such changes to our end users here. So we can say that here just only, that means here the DBMS is the entity where user database designer directly sit on DBMS and uses it here, and the end user just providing here the handy tool. That means here we are not giving any handy tool to our end user to make some changes in our database here. So this is called as the logical one tier in one tier architecture, and logical two tier client server architecture. So what about the logical two tier in client server architecture? So in this case we can say that here, why? Because all those information is there in our database, okay here, and later next one maybe some computer going to use such a database here from the server here. So we can say that why? Because here I already said in one tier architecture here no any users of the database here. That means the end user not providing any handy tool, and here just work that is performed by only by the database designer, and there is no any view of the database here. And later the logical two tier client server architecture. So such a logical two-tier client server architecture is used for user interface program as well as application program, and such two-tier client server architecture that runs on the client side. Why? Because say here this one is the application program, okay here, and maybe some computer or any user want to access any data from the application program. Here they can access the data here. Why? Because here this is used by our end user. They want to access some data from the database. So we can say that the two-tier client server architecture is used for user application, okay here, the user application, user interface program as well as the application program, and that runs on the client side. That means client means user, okay, whatever the data, if any user want to access here such data, they can access to from the application program here, okay. And interface called, the interface name is called as the ODBC. So what's the full form of the ODBC? The full form of the ODBC is the Open Database Connectivity, okay here, the open database. That means in this case to access any data from the database here, the each client program, the each computer need to use some interface. The interface is called as the ODBC. The ODBC full form is the Open Database Connectivity. Clear this point here? And that allow, that means client side program to call the DBMS. Just by using such interface we can call the database. Clear this point here? That allowing the client side program to call the database here. Whatever the data they want to access, such data going to access by using interface. Interface name is called as the ODBC, Open Database Connectivity. So in this manner we can say that the most database vendors here provide ODBC drivers. Why they providing the ODBC drivers? Why? Because the client program to connect the several database, it possible to the client program to connect to the several database database, and such a database going to connect by using the drivers. The name of the driver is called as the interface. Interface meaning the connection. The such connection is possible to access any data from the database to the client program by using the interface. Interface is called as the ODBC, Open Database Connectivity. So this one is called as the two-tier client server architecture. One is the database, second one is the client side computer. Clear this point here? And later next one is about our three-tier, that is called as the logical three-tier client server architecture. Now we already know that. Why? Because logical three-tier client server architecture. Now this diagram is applying to our logical three-tier client server architecture. So what about the logical? That means here we can say that the three-tier client server database architecture is commonly used architecture for web applications. Clear this point? We know that in web so much information is there, but we are going to access or viewing only the desired information from the web in this case here. So just only to access the desired information from the web, we need to use the intermediate layer. So some of or an intermediate layer is going to use maybe the layer like application server or the web server going to use here. Clear this point here? Why? Because this type of the three-tier client server architecture is mostly used by our web application. Clear this point here? The web application in this case here, and in this case, why? Because in our web we need to use some of the intermediate or the mediator, okay, to access all those information. So what are the intermediator or medium going to use? The medium are, one is the application server, or such application only called as the web server. And what's the work that is done by our application server or the web server? So here we can say that this layer act like a medium, okay, and sending processed data, partially the processed data between the database server and the client. Clear this point here? Now let's, in very simple way, I will tell the meaning of the logical three-tier architecture. Now all those data is there in our database tier here, okay, and by using the application that is called as the application server or web server, I am going to access the desired data, okay, just only what's the data I want, such data only I want to access here. So I am going to access this data from the database tier here, and laterwards whatever the data we accessed from the database tier, that is going to present here. So this is called as the three-tier client server architecture here. So clear this point here? Why? Because there are three types are the logical one-tier. In one-tier architecture meaning here, just only the database designer, application programmer using single-tier architecture, and it does not provide the handy tool to make some changes in the database to the users here. Clear this point? In this way we are not giving any handy tool to the end user to make all those changes in the database. So whatever the changes they want to done, such one is going to done by our designers only here. So this is called as the logical one-tier in one-tier architecture. And logical two-tier client server means now so much information is there in our database here. Now maybe some computer they want to access the data. So how they are going to access? By using interface. The meaning of interface is the connectivity. So what's the connectivity? ODBC, Open Database Connectivity going to use here, and by using the ODBC, the data going to accessed by the client side program here. And later next one is the logical three-tier client server architecture, specially for the web application, okay here. And some of the intermediate layer using maybe the web server going to use here. And why they want to use? Why? Because just only to transfer the data, okay here, the processed data that is between our database server and the client. Why? Because I already said many information is there I want to access. So such such information going to access by using application server or web server here, and what's the information we accessed, such information going to present and display, that is called as the presentation layer here, that is called as the presentation tier, otherwise and the client in this case here. Why? Because we know that all those information going to accessed by our client only, the user of the database. And after knowing the types of the architecture or different types of the architecture, let's we select the next concept, that is the database model here. So now what about the database model? So we can say that the database model is simply called as the data model here, and we can say abstract model, and this model describes the how the data is present, represented, structured, organized and used. So this is about our database model. Clear this point here? Why? Because see, why? Because this is very important concept. So here in case of the database model, we can say that the data model is not just only called as the data model, such a data model is also called as the database model here, and such a database model describing something. So what it going to describe? It describes here how the data of the database is organized or how represented or how structured, and after structuring of the data, how the user going to use such a data here. So is simply we can say at how the data is represented and used here. So such a data model here, we can say that consisting of a data structure. We know the meaning of the data structure. Why? Because the data of the database going to represent and use is called as the data structure here. Clear this point? The structuring of the data. So we can say that a data model consists of a set of data structure here, and also it describing the conceptual tool. So why we using the conceptual tool? So such conceptual tool that is used, why? Because to describe maybe the data types of the database here, maybe the relationship between the data of the database and also the constraint of the database here. So what do you mean by a constraint? The meaning of the constraint is called as the rules. What are the rules we are going to use in while going to create the database here and after creating the database here? So we can say that such a data model describing the structure of the data, as well as it also going to describe some of the conceptual tool here. So such conceptual tool means what? Here we can say that data types of the database or the relationship between the database here and some of the rules that is going to apply in our database here. Okay, so we can say that in our database model, not only describe the structure of the data, whether it's just only going to describe the structure of the data. Structuring of the data means how the data is going to organize on the storage medium. Okay, yeah? So we can say that our data model or database model not only describing the structuring of the data here, it also defining the set of operations that can be performed on the data here. That means not just only the structure of the data going to describe, it also going to define what are the operation we performed on the data here. So which kind of operation or different type of the operation we perform on the data. And finally we can say that a data model generally consists of the data model theory and data model instance. Clear this point here? The data model consisting something that is the data model theory as well as the data model instance. Now what do you mean by a data model theory? The data model theory means which is a formal description. Clear this point here, which is a formal description. Why? Because here we can say that how, that means how the data may be represented and used. The meaning of data model theory means it is the same. That means how the data is represented and used. There is no any changes. Why? Because I already said here it is describing structuring of the data and also usable of the data, how the data is going to use here. So we can say that the data model representing or telling or describing, that is the data model theory as well as the data model instance. The data model theory means how the data may be represented and used in this case here. But we know that how it possible to represent the data without using any practical application, correct? No, without using any memory space, is it possible to represent the data? No. So we can say that we know the meaning of data model theory, that means here how the data may be represented and used here. But what about the data model instance here? So such a data model instance means which is a practical data model design. Clear this point? It is a practical data model design for a particular application. What's the database we are going to create? But we know that before structuring, before using any data, first of all we need to arrange the data, correct? Yeah, arrange the data. So we can say that the data model instance just only describing about our practical data model design for a particular application here. Now let's see finally the meaning of a data model. So the process of applying the data model theory to create the data model instance is called as the data model or data modeling. Clear this point here? Here model means design of the database, the design of the, in which manner we are going to design the data, in which structure we are going to design the data. This is the meaning of the database model here. So clear this point here. Why? Because we know that our data model describing, that is called as the data model theory as well as the data model instance, and we already know both the meaning of the data model theory as well as the data model instance here. So we can say that data modeling means the process of applying the data model theory to create data model instance is called as the data modeling here. Now let's, why? Because we know that the meaning of the data model or the database design here. Why? Because model only called as the design of the database here and also the data modeling. And before going to know three models, why? Because the database structure, three models going to use here. So before going to tell about the three model of the database, let's the meaning of the data abstraction. So we know that the meaning of the data abstraction. So what about the data abstraction? Why? Because the main objective of the database system, the DBMS, clear this point here, the database system is to highlight only the essential feature to the users here. That means what's the data is there in the database, just only they want to tell. In this case here, they don't want to tell how they collected the data, how they handled the data, how the data is going to processed, okay, while going to create, while going to arrange in the database here. So we can say that in this case here, why? Because the database system providing only the essential features to the user, it highlighting the essential feature to the users and hiding the data storage as well as the data organization detail, whatever the detail. Now just only I said about the processing of data, handling of the data, storing of the data, each and every process or the rules or the whatever is there, any kind of the procedures is going to hide from the user here, and this is known as the data abstraction. Why? Because we already know about the meaning of the data abstraction here, but also again I repeated the meaning of the data abstraction here. So finally we can say that our database model or data model here defines the logical, the design of the data and also describing the relationship between different parts of the data here. And in history of database design, the three models have been in use here. So what are the models we are going to use? So the models are, or the design of the database are here. The first one is called as the hierarchical model, second one is called as the network model, and the third one is called as the relational model here. So we can say that in history of database design, the three models are going to use here. So the first model name is called as the hierarchical model, second one is the network model, and third one is called as the relational model here. So now let's see the first thing, that is about our hierarchical model here. Why? Because here already I drawn one diagram, and that is suitable example for our hierarchical model. So before going to tell about the diagram, now let's the meaning of the hierarchical model. So this hierarchical model was, we can say that is the oldest type of data model. Why? Because first of all, which model is developed in this case? So we can say that the hierarchical data model is the oldest type of data model, and this model was developed by our IBM. We know the full form of the IBM, International Business Machine, and this model developed in the year 1968. Clear this point here? 1968. But by using such model, how the data is going to organize? So we can say that this model organizes the data in a tree-like structures. Okay, in which manner we are going to organize the data of the database? Why? Because we already know the model meaning is design of the database. By using which design we are organizing the data? So in hierarchical model, the data going to organize in tree-like structures. Clear this point here? And in which we can say that the each child node. So in this diagram, now this is the parent node, and 1, 2, 3 call as the child node. Now later words, these two are the child node here, and this one is called as the parent node. Clear this point here? Why? Because we can say that in hierarchical manner it going to create the records here. So in which the each child node, okay, NODES I am telling, the each child nodes in this case here. Why? Because is also calling as the dependents. Why? Because we already know the child is also always is called as the dependent to the parent in this case here. So the child node is also called as the dependents. Okay here, and the child node can have only one parent node in our hierarchical model. Why? Because when you are going to look this diagram here, why? Because this is the parent node, 1, 2, 3 are the child nodes. Clear this point here? And later next one, now this is the parent and these are the child nodes. This is the parent, these are the child, and later parent node, and these are called as the child nodes in this case. So we can say that why? Because child node also calling as the dependents in this case here, and such a child node can only have only one parent node. Okay here, or the parent in this case here. So clear about in case of the hierarchical data model here. So the database based on the hierarchical data model consists of a collection of the records. Why? Because consists of a set of records in this case here, and all these records are connected to one another. Why? Because many records are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can say that the database based on the hierarchical data model consists a collection or set of records in this case, and all those records are connected to one another just by using the links. So this is called as the how we connected each record in our hierarchical data model. So all those records connected just through or by using the links in this case here. So the link is an association between two or more records. Correct? No? Why? Because by using the link we can create the two or more than two records in our hierarchical data model. Now we know that about the child node, parent node, each and everything. Now let's see about our root node. So which node is called as the root node? Okay, in this diagram. So we can say that why? Because the top of the tree structure. The top of the tree structure here consists of a single node, and this node does not have any parent. Clear this point here? This node not have or does not have any parent, and this node is called as the root node. So in this diagram, now this the first node here, that means the single node, and that node does not have any parent. Such node is called as the root node here. Now this is the child node and child node here, and later words after that, now these are the child. Now this node is called as the parent node. Clear this point here? And later we can say that why, because we are in the concept of root node now. I am discussing about our root node. So we can say that the root node may have any number of dependents. Correct? No? Why? Because here the root node contains several children in this case here. So we can say that the root node may have any number of dependents, and each of these dependents can have many number of the lower level dependents in this case here. Or simply meaning we can say that each child node can have only one parent node, but the parent node can have many number of the child nodes. Clear this point? So this is the main concept about our hierarchical data model. Now let's, why, because we already know in our hierarchical data model one parent node is there, but the parent node can have any or many number of the child nodes here. Now what about the record type, or which one is called as record type? So we can say that the collection of same type of record here. So same type of record is called as the record type. Clear this? Clear to everyone? The meaning of the record type, that means the collection of the same type of record is called as the, why, because here we know that whatever is there in database we are going to arrange in record manner here. So record going to arrange one after the another. So the collection of the same type of record is called as the record type. Clear? Yeah. So later and finally we can say that in this model here, each entity has only one parent, but the parent node can have several children. Okay. Here. And I already said about the diagram. Now just I want to tell about the advantage and the disadvantage of the hierarchical data model here. So what's the advantage of the hierarchical data model? So we can say that the hierarchical data model, in this case we can say the direct access to that means whatever the data we are going to access here, very quickly we can access the data from the hierarchical data model here. So data access, okay, is going to work very quickly in case of our hierarchical data model here. And the second advantage, we can say that both retrieval as well as the update can be highly optimized by our DBMS. Clear this point? So this is the advantage of the hierarchical data model. So the first advantage, we can say that the hierarchical data model here, whatever the data, when you want to access such data, you can access very quickly. And the second advantage, we can say that maybe the retrieval only called as the accessing of the data here. So the retrieval as well as the update to the record, update to the data can be highly performed or optimized by our software. Maybe you want to make some updation very quickly, it possible here, and also the retrieval, it also very quickly possible in our hierarchical data model. But what's the disadvantage in case of the hierarchical data model? Why? Because the main drawback of the hierarchical data model, we can say about our links. Clear this point here? Why? Because whatever the records are there in this diagram, many records are there, and all those records are connected through links here. So the links are hard coded. Clear this point here? Once if the link is going to connect, it's not possible to broke such links in this case here. So the links are hard coded, and and the link is permanently established and cannot be modified. Not possible to change the links here or make some changes in the link here. So whatever the link is going to establish permanently, that means here the link is permanently established and it's not possible to modify the or make some changes in the links here. And later words we can say that the link make it difficult to expand. Why? Because see here root node is that maybe I want to expand in our second line. So is it possible to expand? No, it's not possible to expand in our hierarchical data model. So we can say that because of this link here, the link make it difficult to expand. Expand maybe in case you want to expand any records, okay? If you want any extra record, it's not possible just because of the links in this case here. And finally, maybe you want to make some changes, that means such changes require redesigning the efforts here. So this is the disadvantage of our hierarchical data model here. So now we know that what about our hierarchical data model or the each and explanation about our hierarchical data model. That means the meaning of the hierarchical data model, the full form of the IBM, and when it was developed in this case here, and about the root node, record type, and what about the child node, parent node in this case here, and also the diagram, and finally the advantage as well as the disadvantage of the hierarchical data model. And the second model, that is called as the network model here. So what about the network model? Why? Because we know that the three models have been in use. The first model, hierarchical model. Now the second one is the network model here. So what about the network model? So we can say that, and whether there is any difference is that to our hierarchical model and network model here. Shall we explain? We are going to explain about our network model here. So we can say that the first development or the specification of the network data model was developed or proposed, or we can say that presented by our The first specification of network data model was developed or presented by our CODASYL. So what's the full form of the CODASYL? The full form is the Conference on Data Systems Language. Okay, here, and developed in the year 1969. So the first specification developed in the year 1969, and this specification, or we can say that, followed by the second specification in the year 1971. Not just only first time they developed this the development of the network data model here. That means the first of all it was developed in the year 1969 here, and later all those development, that means here the more development going to develop in the year, or we can say that the followed by the second specification in the year 1971. Okay here, and it is powerful but little bit, we can say that, complicated data model here. Why? Because when you are going to compare to hierarchical and network, so the network data model is a powerful data model, but here we can say that it is little bit complicated data model. Why it is a complicated data model in this case here? Why? Because we can say that in network model the data is represented by a collection of records. Clear this point here? By a collection of the record. Why? Because in this case just only one connection is there, but when you are going to see this diagram, we can say that there is a connection from one to another in this case here. So the data is represented, or we can say that the data is represented by a collection of the records in this case here, and the relationship among the data is represented through links. Why? Because here also the link is going to use to connect the record, to connect the data, or to make some relationship between or among the data. So the relationship among the data is represented by or through links in this case here. So the link in a network data model represents, why? Because here it going to in case of our or we can say that here in case of the network data, the link, whatever the link is there in network data model is going to use in case of the link, correct? No, in this case here, so here also we are using the link. Now what's the difference to our hierarchical hierarchical data model and network data model here? Why? Because the hierarchical data model here, the data organized in the form of trees in this case here, but in case of the network data model, the data organized in the form of graphs. Clear this point here? So this is the difference between our hierarchical network model, hierarchical data model and network data model here. So clear this point here. What about in case of our hierarchical data model and the network data model here? Why? Because see, in this case many link is there. Why? Because I want to make the connection. So the first one is the department here, in department number and name is there, and in case of the next record, that is called as the next table, we can say as the, that is the student in this case here, and it contains some of the records, ID, name, course and the student here, and later next one is the course containing some of the records, number, name, unit here, and later one more, that is the professor containing some of the records, ID and name, and there is a connection between one to another. Why? Because just only I connected from name to the name from each record here. So that means all the nodes are connected to each other but without any hierarchy. Clear this point here? So in case of the network data model. Now what's the advantage of the network data model here? So we can say that the advantage of the network data model here. So the first thing, the parent node, correct? No, in this case here, the parent node. Why? Because these are the parent node, correct here? The first one is called as the parent node and these are called as the child node here. So the parent node can have many child nodes and the child nodes can also have many parent node. So thus the network model permits the modeling of many to many relationship. Why? Because hierarchical data model representing one to one, one to many relationship. So one to one and one to many relationship. But in case of our network data model, it representing the relationship. The relationship is the, we can say that, well, because the parent node can have many child nodes and the child nodes can also have many parent nodes in this case here. So the network data model represents the relationship and the relationship is many to many relationship in the database design or in the data here. So this is the first advantage about our network data model. Now what's the disadvantage about our network data model? So the disadvantage, we can say that in this case here. Why? Because whatever the advantage I said, the same point is applicable or same point going to use for disadvantages only. But before that, I want to tell the first disadvantage in our network data model here. Why? Because the main drawback of the network data model, it can be quite complicated to maintain all the links, correct? No, here. Why? Because here, see, here many records are there. From one record to another record, I connected from name, from first student to the course name student here, or maybe department to the professor name in this case here. So we can say that, why? Because it can be quite complicated to maintain all the links here, and any single broken link can lead to problem in the database. Maybe if any one connection going to broke in this case here, that means it's going to create some problem in the database here. And whatever the advantage I said in our network data model, I said parent node can have many child node can also have many parent node here, correct? No, why? Because it representing relationship, many to many relationship in the database. But also we can say that it only the disadvantage. The disadvantage is since there are no restriction on the number of the relationship. Clear this point here? So it it is very difficult to design, or whatever the database design can become more complex in our network data model here. So clear this point here about the network data model. Why? Because now just we completed the models explanation. In models we know that three types are there, hierarchical model here and also the network model. Now let's see the last thing about our relational model here. Why? Because we know that what's the advantage in our hierarchical and as well as the disadvantages, and also the advantage in case of the network data model and as well as the disadvantage in our network data model here. Now let's the last thing about our relational model. Now what about the relational model? And it was developed by what's the name of the scientist in this case here? So we can say that the relational data model was developed by E.F. Codd. E.F. Codd, C-O-D-D. So E.F. Codd, and it was developed in the year 1970. Clear this point here? Why? Because hierarchical data model developed in the year 1968. Network data model developed in the year 1969, and also the development is followed in the year 1971. Now we are in the concept of relational model here. So we can say that it was developed by E.F. Codd in the year 1970. So in relational data model, it is not like hierarchical and network data model. Why? Because we know that the hierarchical and network data model, we are going to use the links, correct? No? Why? Because of links, the record are going to connect from one to another here. But in relational data model, unlike hierarchical and network model, because there are no physical links in our relational data model. In our hierarchical and network, we are connecting the record through links or by using the links. But in our relational, we are not going to use any pointers or simply meaning we can say as the links in this case. So how we are going to arrange the record here? Why? Because all data is maintained in the form of tables. Clear this point here? So why? Because here no any problem about the connection in this case here. Maybe any connection going to broke. No any problem. Why? Because we know that the relational data model, whatever the data you want to arrange or maintain in the form of tables, and such a table also known as the relations. Clear this point here? And how we are going to create the relation? Such a relation going to create by using the rows and the columns. Clear this point? By using the rows and the columns, all those relation going to create here. Now what do you mean by an attribute of a entity? So we can say that an attribute of a entity means maybe the column or field represent in a table. That means such a column we are going to represent in a table here. Such one is called as an entity. That means an attribute of a entity. But we know that. Why? Because here I already said the connection going to occur by using the links here. But in our relational data model here, how we are going to make the connection from one table to the another table? So we can say that in case you want to make some relation from one table to the another table, so all the relation in between the table is implemented just by using the common attributes of the table or common attributes in the table here. So in this example, the common attribute I want to relate, that is from department number to the department number. That means whatever the column is there, such column should be need in two table also here, just by using the common attribute of the table here, or common attribute meaning the column of the table here. So it's possible to make the connection in between two table here. So this is about, or not by using any pointer or links, we are going to make the connection in between two table in our relational model. Clear this point here? The relational model here. So we can say that when you are going to compare these three model, the relational model is much more easier. Okay, much more easier than our hierarchical hierarchical and network database system. So because this reason, finally we can say that in relational data model has become more popular in this case here, more popular in field like maybe the educational field, industrial field. Nowadays mostly going to use, why? Because whatever the data they want to create, they are not going to use all those model, they just they creating the data by using our relational model here. Okay, so is much more popular in field like education as well as the industry here, and also we can say that much more dominant also when you are going to compare to all these models here. And finally we can say that such relational data model has become much more programmer friendly. So let's see some example for the relational DBMS software. So that means while going to create any table, while going to create any database, then sure we need to use some of these software. So some of the software we can say, or some example for the relational software or the relational model software, we can say as the Oracle, CEBA here, or DB2 database 2 here, or maybe can say Infomix in this case, MS SQL Server are some of the few example of popular relational DBMS database management system here. So that means just only in this class we completed some of the explanation for our models. So the models are hierarchical model, second one is the network model, and third one is about our relational model. Thank you.